Good morning, Jefferson. Welcome to the second week of distant learning. For this week, we are going to be working on the Pythagorean Theorem. For today's lesson, you are going to need your Go Math book, your interactive math notebooks, a ruler, and a calculator. I will be using my phone for a calculator. So the Pythagorean Theorem, we are going to start with our table of contents. 12.1, the Pythagorean Theorem. Now, I am going to do a second lesson tomorrow with the Pythagorean Theorem. The one for today is for two-dimensional figures. Tomorrow will be three-dimensional figures. So I'm going to go ahead and put that. It is a 2D figure, and I believe I'm starting mine on page 6. I'm going to turn over to page 6. I'm going to label this the Pythagorean Theorem. And once again, this will be for two-dimensional figures. Okay. We are going to start off this lesson with a little bit of vocabulary. The first thing I'm going to do is I'm going to draw a right triangle. Now, what makes this triangle a right triangle? The reason why it's a right triangle is that it has a 90-degree angle, and the 90-degree angle for this triangle is this corner. This Pythagorean theorem will only work for right triangles. If a triangle is not a right triangle, this will not work. Okay, so our vocabulary for this right triangle, the two lines that are connected to the right triangle are called legs. The opposite line segment is called the hypotenuse. The hypotenuse is very, very important because it's always going to be the c in the equation. So the equation for the Pythagorean theorem is a squared plus b squared is equal to c squared. This is the leg, this is the leg. C is always going to be the hypotenuse. Okay, so we're going to do two examples of using the Pythagorean theorem. I am going to start with a right triangle. For example 1, my right angle is going to be on the right-hand side. This leg is 7, this leg is 24. My tip moving forward in our geometry unit for all of the equations, write them first before you solve, and that actually helps you memorize them. So a squared is a formula plus b squared is equal to c squared. Leg squared plus leg squared is equal to hypotenuse squared. So 7 squared plus 24 squared is equal to c squared. 7 times 7 is 49. So 49 plus 24 times 24 is 576 is equal to c squared. 49 plus 576 is 625 is equal to c squared. To get c by itself, we're going to take the radical. So radical of 625 is 25 is equal to c. So our answer for this, the missing hypotenuse is 25 inches was the example in our book. Okay, I'm going to do one more example of using the Pythagorean theorem. I have a triangle, a right triangle. I have a 12 at the bottom and a 15 on the hypotenuse. This is a type of question that pops up on the Common Core, and it really tricks a lot of students because we get accustomed to doing A plus B and finding C. In this case, we are given the C, we are given the hypotenuse, but we are not given one of the legs. We're going to do the same steps. We're going to start by writing the formula. But when we are replacing the variable with the values from the triangle, we want to make sure that we do the hypotenuse as the C. We are missing this leg, but we know this one. So we are going to replace only one of these variables. I am going to replace the B. So I have a squared plus 144 squared is equal to 15 times 15 is 225. Oh, my apologies. It's not squared. I already squared it. Okay, how am I going to solve? I'm going to isolate the variable. I'm going to subtract 144 from both sides. A squared is equal to 81. I don't even need a calculator for this one. I know that 9 times 9 is 81. So radical 81 is 9. So for this triangle, the leg is 9.